Lecture 4.3 Bottom-up Techniques for Synthesis of Nanomaterials. The bottom-up approach is a method of nanomaterial synthesis where materials are built atom by atom, molecule by molecule, or crystal by crystal to form nanostructures. This method assembles nanoparticles from smaller units through chemical or biological processes. The common bottom-up techniques are chemical vapor deposition, CVD, or sol gel method, then hydrothermal synthesis, then self-assembly method, or molecular beam epitaxy method, and biosynthesis using microorganism or plant extracts. Let us now discuss these techniques one by one. First of all, let us discuss chemical vapor deposition, which is commonly known as CVD method. This is a process used to produce thin films and nanomaterials by depositing a solid material from a vapor phase onto a solid surface known as substrate. It is a technique in which volatile chemical compounds known as precursor gases react or deposited at high temperature to form a solid thin film or a nanostructure material layer on a substrate. Next is sol gel method. This is a bottom-up chemical technique used to synthesize nanomaterials by converting small molecules into a solid network through solution-based reactions. It is a process in which a colloidal solution, means sol, gradually transforms into a gel-like network known as gel and finally forms nanoparticles or thin films after drying and heat treatment. Next is hydrothermal synthesis. Hydrothermal synthesis is a bottom-up method used to prepare nanomaterials by carrying out chemical reactions in water at high temperature and high pressure inside a sealed vessel called an autoclave. In this technique, precursors react in an aqueous solution under controlled temperature and pressure to form nanoparticles or nanostructures. Next is self-assembly technique. This is the process in which atoms, molecules, or nanoparticles simultaneously organize into ordered nanostructures without external direction. In self-assembly technique, building blocks automatically arrange themselves into stable, well-defined structures due to intermolecular forces such as hydrogen bonding, van der Waals forces, electrostatic interactions, or hydrophobic interactions. Another technique is molecular beam epitaxy, MBE technique. It is a highly controlled thin film deposition technique used to synthesize nanomaterials and epitaxial layers with atomic scale precision. In molecular beam epitaxy, a single crystal is created by building up orderly layers of molecules on top of a substrate. It is a method where atomic or molecular beams of elements are directed onto a heated crystalline substrate inside an ultra-high vacuum chamber. The atoms condense and arrange themselves layer by layer, forming extremely pure and precisely controlled crystalline films. We also have biosynthesis methods of nanomaterials, in which biological systems such as microorganisms like bacteria, fungi, algae, or plant extracts are used to produce nanoparticles in an eco-friendly way. This method is also called as green synthesis of nanomaterials. Biosynthesis is a process where biological molecules like enzymes, proteins, sugar reduce metal ions into nanoparticles and also stabilize them. For example, silver ions can be reduced to silver nanoparticles, gold ions can be reduced to gold nanoparticles. There are many advantages of bottom-up approaches. The bottom-up approach allows for precise control at the atomic or molecular level, leading to well-defined nanomaterials with specific properties. Since the materials are assembled from individual atoms or molecules, there are few defects compared to the top-down approaches. The bottom-up synthesis can result in unique nanomaterials with properties that are not easily achieved through top-down approaches. The disadvantages of bottom-up approaches include that these can be more complex and expensive, especially for large-scale production. Some bottom-up approaches may not be easily scalable for mass production, limiting their industrial applicability. Achieving high purity and reproducibility in bottom-up synthesis can be challenging due to the involvement of intricate processes. In conclusion, the bottom-up approach allows for greater control over nanomaterials properties and can potentially lead to unique properties not found in their bulk counterparts. However, it can be more challenging to scale up these processes for mass production compared to the top-down approaches. Both the top-down and bottom-up approaches have their advantages and disadvantages, and researchers often choose the most suitable method based on the specific properties and applications of the nanomaterials they aim to create. Additionally, a combination of these approaches, known as hybrid approaches, can be used to achieve even more complex nanoscale structures with tailored properties. You can find many videos on nanotechnology and nanomaterials on my YouTube channel, PHYSIFER. Thank you. Thank you.